All right, what's up guys? So I hope you're doing good today. Today we're moving on to lesson 5.8, and the next two lessons we're gonna be learning about two types of special right triangles. And one of those special right triangles is gonna be known as a 45, 45, 90 right triangle, okay? So let's get into the lesson and let's jump into it. Okay, so the first thing I want to talk about is specifically what I mean by 45, 45, 90. So when we're talking about these two types of special right triangles that we're going to be talking about in this lesson and the next, I'm talking about the angles, okay? So 45 and 45 and 90 are the angle measurements of your triangle. So this is a right triangle. So I have a 45, 45, and 90 right triangle, okay? And so there's going to be a special relationship between all these sides that if I know just one side measurement, I then can find the other side measurements by using this special right triangle, okay? So let's go and look at the definition real quick. So it says here, an isosceles right triangle has two congruent side lengths we call x. Using the Pythagorean theorem, we find that the hypotenuse is that a leg length x times the square root of 2. Let's label the right triangle with this relationship. So right now, let's go ahead and look at this. So let me do my writing utensil here. Okay. All right. So right here, if I have triangle, right triangle, okay, my two legs here on an isosceles triangle are going to be congruent. So I'm going to label both of these as x, okay? And so right now, if I was to plug this into Pythagorean theorem, x and x would be my two leg lengths, right? So x squared and x squared. So if I put those together, combine them, that would give me 2x squared, correct? Does that make sense? Okay, and so now in order to solve for c here, I'm gonna have to take the square root of both sides here. So whenever I do that, that just gets rid of my squared, okay? And so now I can factor it out, so then it becomes x times the square root of 2, basically. That's what it's gonna factor out to. So that means the hypotenuse here is gonna be x square root 2. So right now, this is gonna be the template that you need to memorize. So on a 45, 45, 90, both of my legs are going to be congruent to each other. Then to find the hypotenuse, all I have to do is take that leg measurement and multiply it by the square root of 2, and that's going to give you the hypotenuse. So we're going to take this concept, we're going to apply it to our examples, and it should be pretty simple for you guys. So let's jump over to those examples. All right, so on example number 1, it says here we need to find the lengths of the legs for this triangle, okay? So with that being said, if we look at this right triangle, again, I have a 45, 45, 90 right triangle. So I know there's that special relationship there. So what I'm gonna do so you can see it visually is I'm gonna redraw the template over here. So right now, if you have a 45, 45, 90, I know my two legs are gonna be congruent to each other. Then to find the hypotenuse, all I have to do is multiply that leg length by the square root of 2, okay? So right now in this example, I'm given the hypotenuse already. So I know if I'm gonna go from a leg to the hypotenuse, all I have to do is multiply by the square root of 2. So going from here to here, I multiply by the square root of 2, right? So now to go backwards, to go the other way, the opposite of multiply is divide. So that means if I'm gonna go from 24, which is my hypotenuse, to my leg, I have to divide by the square root of 2. So what I'm gonna do is I'm gonna take that measurement and I'm gonna divide by the square root of 2. So technically speaking, I could type this into the calculator and get a decimal and it would give me a decimal length. But sometimes working with radicals and keep it in a radical form is gonna make it a lot easier. So whenever we did simplifying radicals, remember, you can't have a radical left on the bottom. So what I'm gonna do is I'm gonna multiply by square root of 2 over square root of 2, which then is gonna turn into 24 square root of 2, and then 2 times 2 gives me the square root of 4. Well, the square root of 4 is gonna give you 2, right? So I'm gonna be left with 24 square root of 2 divided by 2. And then lastly, 24 divided by 2 is gonna give you 12. So that means this is gonna finalize into 12 square root of 2. So that means one leg measurement here is gonna be 12 square root 2. But again, in a 45, 45, 90, both legs are gonna be congruent to each other. So if this is 12 square root 2, that means this over here is gonna be 12 square root 2. And actually, if I typed that into the calculator and did 12 times the square root of 2 and clicked enter, it would give me 16.97. So that means if it asked you for a decimal, this would be the actual measurement. But the reason why we leave it in radical form is if we keep doing work with it, it's easier to just keep it that way, and it's actually a more accurate answer if we leave it in that form, okay? So let's move over to example number 2. All right, looking at example number 2. So right now it says, what is the length of the hypotenuse here? So again, recognizing I have a 45, 45, 90 right triangle. So that means there's that special relationship again. So if you have the special right triangle, I know that both of my legs are going to be congruent to each other. Then to find the hypotenuse, all I have to do is take that leg and multiply by the square root of 2, okay? So right now, if you look at your triangle here, I'm already given one of the legs. So if I wanted to find the other leg, that's simple. The other leg is just 7. It's the same, x and x. Then to find the hypotenuse, all I have to do is multiply by the square root of 2. So that means all I have to do is take 7 and multiply it by the square root of 2. So if I wanted to leave it in radical form, this would be the simplified answer because I can't do the square root of 2. So now if I wanted to get an exact decimal, I would do 7 times the square root of 2, and then that would end up giving me 9.89, which if I wanted to round that, it would then turn into 9.9. So this is the decimal answer. This is going to be your radical answer if you wanted to put that, okay? Pretty simple. Move it over to example number 3. All right, now looking at example number 3 here. So it says on 3, it wants you to find the value of y. So right now on this right triangle, again, I'm going to keep saying it. I have a 45, 45, 90 right triangle. So that means there's that special relationship again. So if I was to draw my right triangle here, both of my legs are going to be congruent to each other, x and x. And then my hypotenuse, I'm going to take that leg and multiply by the square root of 2. So just like example number 1, we have the hypotenuse. Now I need to end up finding the leg. So I know if I'm going to go from my leg to my hypotenuse, I'm going to multiply by the square root of 2. So that means if I go backwards, back to the leg, I have to divide by that square root of 2. So let's go ahead and take this hypotenuse, divide by the square root of 2 to get to y. So I'm going to do 11 square root of 2 divided by the square root of 2. So if you look here, square root of 2 over square root of 2, this is actually going to cancel, okay? So that means I am going to be left with 11. So that means your y value here, which is your leg, would end up being 11, okay? Which, if I wanted to find the other one, the two legs in a 45, 45, 90 are going to be congruent, so that would be 11 as well. Pretty simple. Moving on to example number 4. All right, and lastly, on example number 4, it says a square has a diagonal length of 13 meters. What is the side length of that square, okay? So first thing is, we need to go ahead and draw us a square. So in a square, I know if this is indeed a true square, that means all of these measurements on the side lengths are going to be congruent to each other. So I'm just representing it as x all the way around the board. So it tells me it's given me a diagonal of that. So the diagonal is going to be 13 meters. Well, I know that every single one of these angles all the way around is 90 degrees. So if I draw a diagonal, it's going to cut those in half. So that means this is going to be 45. And this is going to be 45, which makes this 90. So with that being said, I have a square with a diagonal that cut that into a 45, 45, 90 right triangle. So again, 45, 45, 90 has that special relationship. So with that being said, I'm going to draw my template here to kind of give me the idea of what I'm doing. Both my legs are going to be congruent. Then to find the hypotenuse, I'm going to multiply by the square root of 2. I don't know why I put 13. Square root of 2. Perfect. Okay? So now look, right now on this triangle, I have my hypotenuse, so I need to get to the leg. So I know to go from the leg to the hypotenuse, I would multiply. Then to go back, I would end up dividing. So I'm going to actually do the hypotenuse divided by the square root of 2. So I'm going to do 13 divided by the square root of 2. So again, I could just type that into the calculator and it would give me a decimal. But if I need to leave it in radical form, I'm going to show you guys how to do that way first, okay? So again, I have to get rid of the radical on bottom. So I'm going to multiply by 1, which is going to be square root of 2 over square root of 2. 13 times square root of 2 would give you 13 square root of 2. 2 times 2 gives you 4. Then the square root of 4 would turn into 2. So your simplified answer for your leg measurement would actually end up being 13 square root 2 over 2. That would be the radical form there. But if I actually ended up typing that into the calculator and I got the decimal, so 13 divided by the square root of 2 is going to end up turning into, which the decimal would end up being 9.19. So that would be your decimal measurement on that, okay? So ladies and gentlemen, this is how you use a 45, 45, 90 right triangle, and you guys can jump into the skill check. Let me know, please, if you have any questions. Good luck.